Welcome to this maths grind on coordinate geometry distance. We will begin by looking at the distance formula. The distance formula can be found on page 18 of the log tables. The distance between 2 points A and B can be found by substituting the coordinates into the formula directly. Example question. Find the distance between the points A, 2, 3 and B, 5, 7. Using the formula, the distance from A to B is equal to the square root of x2, which is 5, minus x1, which is 2, all to be squared, plus y2, which is 7, minus y1, which is 3, all to be squared. We must now simplify to give the square root of 9 plus 16. Our final answer, the distance from A to B, is 5 units. We will now look at the Pythagoras theorem equation, which can be used to find the distance between 2 points that are plotted on a graph. The Pythagoras theorem equation can be found on page 16 of the log tables. The C value in this equation must be the length of the hypotenuse in a right angle triangle. Example question. Find the distance between the points A and B as shown on the graph below. First, we must construct a right angle triangle with the line segment AB as the hypotenuse. The lengths of the horizontal and vertical side can be read from the axis. These lengths can then be substituted directly into the formula, giving c squared is equal to 3 squared plus 4 squared. We must now simplify, giving c squared is equal to 25, and then c is equal to root 25. Our final answer, the distance from A to B, is 5 units. We will now take a look at the converse of the distance formula. If the distance between 2 points is known, then the distance formula can be used to find an unknown quantity of the points. The distance formula is a surd equation. A surd equation exists when there is a square root function on a variable. To solve a surd equation, both sides must be squared to remove the square root function. Example question. The distance between point A, 2, 3 and B, 5k is 5 units. Find the possible values of k. We start by substituting all known values into the distance formula. So 5 is equal to the square root of 5 minus 2, all to be squared, plus k minus 3, all to be squared. As this is a surd equation, both sides must be squared. The squaring of both sides gives us 25 on the left hand side and removes the square root function from the right hand side. We must now simplify this equation to solve for k. So 25 is equal to 9 plus k squared minus 6k plus 9. We can rearrange this quadratic equation. The quadratic can be solved by factorising. The factors are k minus 7 and k plus 1. These factors can be solved for k, giving k equals 7 and k equals minus 1.